Hi, welcome back. This is Professor Age, and today's lesson is on Section 8.8, Probability. Experimental probability is discovered by observation and study of data. Okay, so for example, say you flip a coin 100 times and it lands on heads 47 out of the 100 tosses. Okay, so the experimental probability would be 47%, or 0.47. Theoretical probabilities are determined by mathematical reasoning. So example, for tossing a coin, a fair coin, meaning it's equally likely to land on heads and tails. Okay, so tossing a fair coin is equally likely to land on heads or tails. Then the theoretical probability would be 1/2 or 0.5, right? Whichever way you want to write it. Okay, principle P, experimental. So given an experiment in which n observations are made, if a situation or event E occurs n times out of n observations, then we say that the experimental probability of the event, so the way you write that is P of E, probability of E, is given by, so we got P of E equals M divided by N. So the number of outcomes M divided by the total number of observations. And so it's a big idea there. Okay, so in a box of gumdrops there was the following number of gumdrops. There was 9 orange, lemon was 8, strawberries 7, grape 6, lime 5, cherry 4. So if we take one gumdrop out of the box, what's the probability of getting a grape gumdrop? So this is our experimental probability because we observed these numbers. So what's the probability of getting a grape? Well, the number of grapes in the box was 6 divided by the total number. Let's see, so the total number is 9 plus 8 plus 7, 6, this is going to be my n, plus 5 plus 4, okay, 39, and that reduces down to 2 13ths. So that's our experimental probability. Okay, suppose we perform an experiment, such as flipping a coin, throwing a dart, drawing a card from a deck. Each possible result of such an experiment is called an outcome. So outcome is, what's the result of doing an experiment, whatever the experiment is. The set of all possible outcomes is called the sample space. And an event is a set of outcomes that is a subset of the sample space. So again, the sample space is all the possible outcomes, and then the event is just a subset of that. Okay, so principle P, theoretical. So if an event E can occur n ways out of n possible equally likely outcomes of a sample space S, then the theoretical probability of the event, P of E, is given by, so it's basically the same formula like the observed. So n is the number of ways that you can get the event divided by the total number of outcomes. But here's an example. What's the probability of rolling an even number on one 6-sided die? So our sample space is going to be, you can get a 1, a 2, a 3, 4, 5, a 6. So n is going to be equal to 6. And our event E is going to be equal to getting either a 2 or a 4 or a 6. So M is going to be, there's 3 ways to get an even number. Probability of E is going to be equal to M divided by N, 3 divided by 6, which is 1/2. No, we'll probably write probability of getting an even. That's usually what we do, something like that. Let's try another one. Okay, what's the probability of drawing a face card from a well-shuffled deck of cards? So we know our sample space is you can get any of the 52 cards, one card, so Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, which is a face card, Queen is a face card, and King. And then you have 4 suits, so there's 12 of those. The probability of face card is the number of face cards divided by the total number of cards. So that's going to be, there's 3 for each suit, there's 4 suits, so it's 12 face cards, 52, and that reduces to 1. Let's see, what does that reduce to? You can divide out a 2, so that would be 6, divide out a 4, or another 2, so it would be 3, 13, 3 out of 13. Alright, some properties for probability. Probability properties. The first one is if an event E cannot occur, then the probability is 0. Okay, so if an event E is certain to occur, if you know it's going to happen for sure, then probability E is equal to 1. So 1 is for certain, 0 is it can't happen. And typically the probability event is somewhere in between 0 and 1, but it could be equal to 0, it could be equal to 1. So it has to be in that range. Let's do one more example, not dealing with those probabilities, but properties. I mean, just let's look at one. Suppose. Okay, so suppose 4 cards are drawn from a well-shuffled deck of 52 cards. What is the probability that they are all red? So remember, probability that they're 4 red is equal to the number of ways to draw 4 red over the total number of ways to draw 4 cards. Okay, and it doesn't matter. So basically this is, we're going to do how many ways to draw 4 reds. Well, there's 26 red cards, choose 4. And how many ways to get 4 cards? Well, there's 52 cards, 52, choose 4. And we'll just put this in our calculator here. Well, 26 times 25 times 24 times, 24, 23 over 4 times 3 times 2 times 1. 52 times 51 times 50 times 49. 4 times 3 times 2 times 1. So if I flip it over, we get 26 times 25, so the 4, 3, 2, 1s cancel. 24, 23 over 52, 51, 59. Let's see, 51 goes into, I can get 3 out of that. 3 out of that. 2 2s 4, so it leaves 2. So I'm going to get 2 times 23 is 46 over 17 times 49 is 833. So that's the probability of drawing 4 red cards out of a deck of 52 cards. Alright, so that concludes the lesson for 8.8. Go to My Math Lab, complete the exercise there, and I'll see you next time.